Hello guys, good morning Hey, sorry guys, went for toilet. Okay, uh, let's see Okay guys, I believe those who are here who's actually under Selangor paper Okay, if you are not in Selangor, probably you're already done with exam. Okay, but never mind, guys. As what I said, this class is just a backup video. Okay. Just in case that the tips is actually accurate because not sure whether the tips is actually accurate. Okay. So just guys, just to clarify first, the tips is just a guideline. Okay, so you all don't just study the tips, even though I know the tips recently quite accurate. Okay, so for don't bet your whole life on the tips. Okay, can okay. So guys, before I start, I'm gonna give you a link. Okay, with the PDF inside. Can so my point for now, guys, this class because according to the tips, there are many topics not coming out in trials. Okay. The topic I see actually quite okay quite easy so I'm gonna go through actually the important ones. Okay. I actually included all the subtopics inside So to see whether actually can hit or not. Okay. Let me give you a link. Okay, for those who are watching this on YouTube, because guys, I'll post this on YouTube. Those who are watching on YouTube, okay, the link I'll post in the description box. Okay, so for those who are here, you all can click the link here that I shared in the chat box. Okay, guys, you all can click, and then inside got two PDF one is your student copy, one is the answer. Wait, people coming in Okay, so guys, as I said, okay, this class is not I hope this class is not gonna be a very long class because it's a Sunday morning. So what I can do, guys, here because I just give you guys the PDF This PDF I just done yesterday. Okay, I'm so sorry about it. Okay, so this PDF, right? There are two versions, the question and then also the answer. So what I will do is, guys, here I will discuss. I'll go through with the question and answer, question answer, question answer, and then if okay already finish. Okay, if any question you all ask in the chat box. If no, if after finish already then you all try not to refer to the answer and then try to do it again. Okay, so it's something like I go through first. Okay, make sure you guys understand. After you guys understand, then you all actually do it again using your own understanding. Okay, then only you check the answer again because I don't want you guys to just copy answer and stuff. Okay, because right now I just give you all PDF your copy now also no point one. Okay, so I just go through, okay, a class that goes go through and then see whether which part you don't understand. You let me know, okay, in the chat box I think there are students here that usually not in my class also. So don't worry, guys. Okay, just ask. Don't be shy. Okay, let me share my screen first. Yeah. Then I share the PDF again. Okay. Wait. Cannot view the PDF, is it? Guys, anyone still having issue with the PDF? Or you all just came in? Wait, because I shared the link just now. So if you just join, maybe you don't have it. Cannot open, is it? What's inside? I mean, like what you all see. Like you click in, then error or what? Can only view one page. So cute one. Eh? Can view got other people can view Also guys, let me know. Who can view, who cannot view. Mainly I want to see can view can eh majority can Hmm. Okay, why so cute Okay, never mind. Probably something wrong with the internet, with your internet lah. But never mind, guys. Let me try to upload it because I realized that Zoom can upload PDF now. Uh, Open this. Yeah. Sent the wrong chat. Sorry, Rashmika. Okay. Okay, guys. Those who cannot view, you all try to get the PDF in the chat box. Gotta. Okay. And according to the tips, okay, guys, according to tips, I send you all the tips also, this one is the tips, okay. But whether is it paper one or paper two, I don't know, guys, really, because this is the only version I get until now. Unless you all have a latest version, maybe if you all have a different version from me, you all let me know. Okay, then I separate do another video for that lah. So this video guys, this class is meant for only these tips. Okay, whether set one or set two, I'm not sure. Because the later you are to the nearer you are to the exam, right? Technically the tips is more accurate lah. But for this one, I just try my best. Okay, this video is meant for these tips. Okay, so as you can see, got question one, the easy one, this atomic structure, and then got ikatan kimia, which is called chemical bond. Okay, this one's so wide. Okay, chemical bond got so many bonds. We have like ionic bond, we got covalent bond, we got dative bond, hydrogen bond, and then got metallic bond. Okay, they never say anything about this. Okay, so I just included all questions okay, all topics inside, and then got cosmetic. Okay, cosmetic in most of the classes I haven't teach, but I still include the question here so just in case. And then alloy, and then got glass. Okay, then logam paalihan is transition element. Okay, so which is technically your chapter 4 of your form 4 transition element, where you learn the act as catalyst, the special characteristic form colored ions and stuff. And then got ester, got rusting of iron, got carbon compound, and synthetic rubber. Synthetic rubber, for those who just in normal class, you supposed to just learn this last month, last technically last week lah. Okay, and then got heat of neutralization, heat of displacement, and then got rate of reaction. Karadina balas is rate of reaction. And then got acid, which is the presence of water. You need to know, let the teacher know if got water, what happened to acid, what happened to alkaline. And then lastly, guys, this is the I would say the hardest part, okay, because they say got penyediaan larutan piawai. Means basically you have to actually prepare your standard solution. I bet most of you guys right now don't even know what is a standard solution. What is a standard solution? A solution that is standard? No. So standard solution is actually where the solution, you know the exact concentration. We call it a standard solution. And how you prepare a standard solution usually come from two ways lah. We come from a powder form, or we come from a liquid form. Okay, so guys, so let me go through a few things first. Okay, so guys, as you can see, all my PDF here is already got answer lah. Just gonna go through again, highlight some keywords. Okay, since you all have a PDF, you all can highlight whatever you want lah. Okay, people still joining in though. Wait, let me put the link. Okay, so in question one, guys, so our forecast right here, guys, this is called forecast. We don't say tips or prediction. Okay, so in a very atas word, okay, forecast. Okay, so as we can see, the first question is called atomic structure. So atomic structure actually kind of too little info. Because atomic structure usually just have to write like electron arrangement like 2.8.1, 2.8.2, okay. But I try to include more stuff inside here lah. So I included like 2 or 3 questions about this chapter. Okay, so including your heating and cooling curve, just in case. So of course, the first thing here, guys, is the melting point of your acetamide. Okay, guys, for this heating and cooling curve, right? Sometimes it's naphthalene, sometimes it's acetamide. Okay, so these two is your major chemical that you like to use in heating and cooling curve. And then they say the temperature of acetamide is recorded every 3 minutes when it is left to cool down at room temperature. So what is the meaning of melting point? Guys, they love to ask definition like something like this. Okay, so what is melting point? You have to say it's actually a temperature where your naphthalene. Why naphthalene here? So cute one. So here is acetamide. Guys, sorry, my bad. Yesterday I typed, I copy paste, forgot to see. So acetamide, okay, changes from solid state to liquid state at specific pressure, and you must also include the constant temperature. The constant temperature where something change from solid to liquid or liquid to solid or maybe liquid to gas. Okay, as long they ask you the point, the definition of a point, melting point, boiling point, freezing point, condensation point, any point they ask you must be a constant temperature where the state changes, okay, at a specific pressure. I must include this word specific pressure and constant temperature. So these two very important keyword. And then when you do heating and cooling curve, especially heating, right? You have to actually include a water bath. So the water bath is for what? So you can say water bath is for you to ensure your heating is uniform. Uniform heating, even heating. Sometimes you all use the word even, it's fine. Heating evenly, heating uniformly is both okay one. And then another substance that can use this method, naphthalene. Just like I say, this heating cooling curve only got two, naphthalene or acetamide. So this is the other one. Can And sometimes when they give you heating questions, right? They give you something like this. Sodium nitrate has melting point of 310. Can the melting point of sodium nitrate determined by using water bath? Guys, if you see something like this, think about it. Water bath, the maximum temperature for water, we know is 100 degrees Celsius. If your chemical now is over 100, then cannot. So the answer here, it cannot, because melting point of sulfur, why sulfur again? You guys, all this typo, my bad. Sodium nitrate, okay, it's above the boiling point, which is 100 degrees Celsius. So you cannot use water bath. So instead, what can we do? If you cannot use water bath, we have another alternative. We call it oil bath. Then explain why temperature remain constant. This is also a very common question. So we say temperature constant during change of state. Let's say during its melting, during its boiling. Okay, so you say that heat energy absorbed is used to overcome the force of attraction between particles so that your liquid turn into solid. So this is the keyword for heating curve. Then why do we need to stir? So when we heat halfway through, we have to stir with your thermometer. Okay, stir the boiling tube to ensure temperature is uniform. Okay guys. Okay, so you put water bath, ensure uniform heating. Okay, you stir is to also ensure your temperature is uniform. Okay, why must temperature uniform? Because heating usually like the bottom part very hot then the side, the top not heated evenly. So we're gonna stir it out so that it's your top, the side of the wall, the side of a chemical, the top and the bottom, they are all like mixed up together. Then the temperature is like more even in the whole chemical. So this will be the boiling point test, the heating test. And then if you terbalik, okay, you go down, we have a cooling curve. Cooling curve, it is something very similar. What's the freezing point of acetamide? So they say this is a cooling of liquid acetamide. So means in the starting here, this is a liquid. Then if you cool it down, cool it, eventually it becomes solid. So what is the freezing point? So freezing point must be a point, means must be a temperature. So temperature will be right here, the center, the point where it's actually a constant temperature. So we call this the T2 degrees Celsius. Okay, guys. So in exam, if they say find the freezing point and it's an unknown, you must give me the unknown and together with the unit. Okay, please. A lot of people miss out this part. A lot of people can give me T2. This one okay. But a lot of people forgot to give me the unit. Okay. Degrees Celsius must also include. If never put in degrees Celsius, teacher can give you wrong. Okay. Then the opposite question of this, why temperature go down also have the constant? Because go up constant, go down also constant but the explanation is different So heat loss to the surrounding is exactly balanced by the heat energy release as the particle attract one another to form your new state called solid for here So you must see a keyword So heating curve remain constant. This is a keyword. Cooling curve remain constant. This is a keyword. So guys, I purposely put multiple like different type of question in one so just so that you all can have a general refresh also. And then suggest the physical state for PQR at room temperature. Guys, room temperature, you all write down. Room temperature is usually around 25 or 27 degrees Celsius. So what you're going to do is, you try to do something like this. Okay, so let's say we have a melting point. Melting point, before melting point is a solid. After melting point, but haven't go to boiling point yet. After melting point, so we can say it's a liquid because melted mah. Then if it's liquid, then now you hit boiling point, usually it's a gas. Correct? So I write down in a solid, liquid, gas like this. Is because to let you all see, like if now is it 25 or 27 degrees Celsius, is it a solid, liquid, or gas state? So for example, let's say if I take 25, 25, if I try to compare negative 183, is it more or less than negative 183? I will say it's more lah. So if you see more than this, then you'll be around here. Then do you see 25 is also more than negative 89? So I will say 25 falls around here. Okay, because it's bigger than this, bigger than this. So it will stay at the most right. So I will say your P is gas because 25 is higher than melting and also boiling point. But if you see the next one, 25 is more than 15, but less than 70. So in between melting and boiling. So it's melted but not boiled. So we can say that 25 is here, it is a liquid state. Then R is not even melted. So I would say that your R is around here. Okay, so it's solid lah. So guys, hopefully this had a quick go through, okay, for the easy type of question. Okay, going down, okay, this is chapter 3 lah, even though the tips don't have, but I still give you a bit. Okay, so the meaning of isotope: atoms of the same element with the same number of proton but different number of neutron in an atom. Guys, in an atom, guys, this whole thing must word to word memorize. A lot of people they say, oh teacher, isotope I know, same number of proton but different number of neutron. Guys, this is a keyword, you are not wrong. But to score full mark, I mean, it's actually just 1 mark lah. If not, if you cannot get the 1 mark. Okay, to get the full 1 mark, you must include atoms of the same element. Must read this word also. Okay, don't say, oh, just include this at this, and then you thought can get 1 mark. No. Okay, to get the 1 mark, very strict. You must memorize the full sentence. Okay, and then with the diagram given here, determine proton number. Number of proton will be 11 lah. So guys, as we see from here, 23 and 11 just in case you didn't know, 23 is nucleon, 11 is proton. Okay, can okay, then sodium in our life, okay, sodium 24 is basically the radioactive isotope. The radioactive isotope. So, okay, to detect the leakage for underground pipe. Okay, can and then of course going down, you can see draw the atomic structure. So you follow the proton number. This one 2.8.1. Guys, I believe I don't have to teach you guys how to write out electron arrangement. Can all good. So just this one 281. Okay, so this one 281. And if it's atomic structure, guys, atomic structure, your nucleus must state your proton and neutron. Means atomic structure include this. Okay, include proton, include neutron. Okay, can unless they say electron arrangement, then only you draw this. Means your electron arrangement, your nucleus can be a dot. Okay, just like this, or maybe with a symbol doesn't matter. So as long if you see electron arrangement, then you can draw like this. 281. Like that lah. Can but of course, if it's a atomic structure, beware on this. Put in your proton and neutron. Can okay, then going down, we got atom TUV. Okay, this table given just a quick go through. What is the meaning of nuclear number? Total number of proton and neutron in the nucleus of an atom. Guys, these are also very important. A lot of people still give me the same mistake. They tell me, teacher, nuclear is proton plus neutron. No marks. You have to say total number of proton and neutron in the nucleus of an atom. Never write this, also no mark. Okay, can So if you want to find neutron number of your atom B, you take your nucleon minus your proton. So 24 minus 12, you get 12. Okay, then going down, isotope. Okay, who is isotope? State me a pair of isotope. Same number of proton, different number of nucleon. Right? I would say T and U is my answer lah. So why? Because they got the same number of proton, but different number of neutron. Okay, and then they are the same element, atom from the same element. Okay, and with this, right, say the use of atom U. Okay, atom U is what? Is the 24. Again, sodium 24 is for your leakage of underground pipe. Okay, to detect your leakage. Can talking about underground piping, guys. Recently got the incident accident on the someone who actually fall into the sinkhole in KL. So underground piping is one of the main reason for that to happen, because if your piping underground is having leakage, so the water gonna flow out and then go to the soil. So if water flow to the soil and then it will eventually creates a flow of water that will wash away and make your soil become less strengthened, and then maybe sometimes it causes like sinkhole. Okay, so this is very important in life. Okay, then going down, percentage of natural abundance, guys. Natural abundance there technically is uh the percentage of this atom, okay, occur naturally. Okay, can you see that? So silicon, okay, is 2814, silicon 2914, and 3014 is 92%, 5%, and 3% respectively. Calculate relative atomic mass, guys. Remember, when we take relative atomic mass, it's not just taking 28, 29, or 30. No, we take the average. So how do you calculate average? Okay, percentage multiply the mass. Percentage multiply mass. Percentage multiply mass. So once you multiply all of them together, you see, then you can actually total up, divide 100, you get the average is 98. Okay, if you get a decimal place, you put in also lah, doesn't really matter, because this number I think very near to your 28, because it's 92% of 28 mah. So very near to 28, we just take 28. Okay, and then one example of isotope used in medical field, medicine field, cobalt-60 for peel cancer cell, iodine-131 for thyroid disease. Okay, so these two is a sample for medical field. Okay, so if you say, okay, going down, guys, this one is into your covalent bond, ionic bond already. So question 3 is your bonding. So bonding, I will give you two samples here. Compound A, compound B, obviously, guys, you see the drawing. This is sharing. This is having your positive and negative marker. So this one is, so compound A can be covalent, and compound B is ionic. Okay, what I'm afraid that, because this is actually, okay, according to the tips, ionic bond, covalent bond, this bonding is only on question 2. So question 2 actually, as you all know the trend of your question, usually the beginning questions are quite easy one, okay. So I give you the full essay question here, because it's an overall refresh, okay. So if you can do essay, you can do question 2. Okay. So what they do is they say R react with P to form A. Okay, R and P to form A. And then R react with Q to form B. Okay, so R react with Q to form B. This is the information given. State the type of bonding in A and B, and then explain the formation of the compound. So guys, I just gave you the answer. So from what we see from here, type of bonding is covalent for A, and then ionic for B. And then the electron arrangement given here. Okay, P is 2.4. Okay, guys, follow this. 2.4. R is 2.6. Okay, and then Q here is Q slightly different. Because Q, even though is 2.8 here, but you have to know it's 2.8 because he donated 1 electron. So originally, his original electron arrangement supposed to be 281. And P and R can be actually get accurately, because covalent don't donate, and they don't like lose and gain electron. So the electron they have is their original electron. So from here, on what we see from here, so after you know your PQR, okay, guys, so for compound A, just now we say is covalent. So covalent, the hint, guys, the trend actually very similar one. Ionic covalent, the trend to explain is almost the same, but there are some different structure. Okay, let's see. So we say P, okay, electron arrangement, guys, always start with your stating out electron arrangement. Okay, then P, you see, the sentence starts different stuff up here. You say P need 4 more electron, while your R need 2 more electron to achieve stable octet electron arrangement. Okay, but how are you gonna explain ionic? If it's ionic, it's lose and gain electron. So you have to say, okay, you see, your Q donate 1 electron, to form Q plus to achieve stable octet electron arrangement, while R accepts 2 electron, or you can say gain, up to you, into the outermost shell to form R2 minus to achieve stable octet electron arrangement. So with these two, guys, you see the main difference. For covalent, you have to use the word how many more. Okay, you have to say P how many more, R how many more, like something like how many more for him to become stable. For Q, for ionic, you're gonna talk about how many electron you donate, how many electron you gain. Okay, and also we see with the 4 more and 2 more, your 1 atom P will combine with 2 atom R by sharing electron. This is covalent. Okay. And then you also have to say how many 1 atom P contribute 4 electron, and each of your 2 atom Q contribute 2 electron. So this is all the special writing for covalent. Okay. But for ionic, how to write? Ionic actually finish already, you see. You just say donate how many, accept how many, and then you say that your oppositely charged ion, Q plus R2 minus, strongly attracted to each other by strong electrostatic forces. Okay. So guys, so this is the difference of your ionic and covalent. Okay, can I see the covalent compound later on, you can say double covalent bond form, covalent compound PR2 is formed. Okay. Can so of course here you've also formed Q2R, okay, the ionic compound Q2R. So just hopefully later when you all do this PDF yourself, right? Right, guys, as I said, here I discuss later you all understand already, you all do yourself, you all don't check your answer, try to do, see whether you all can get a full mark or not. Okay, but one thing here, you see, they never say the type of bonding for A and B. Okay, you all write down lah. A is covalent, then B is ionic. Okay, so just to let you have a better idea about ionic covalent, just go through essay, then you can have a better idea. Hopefully, you can also do the easy question because question 2 quite easy. Okay, then going down, guys, got more question about ionic covalent. So this one same, similar. You're gonna use the same concept to actually do this. Okay, but then one more thing, guys. Next page, this one, the first part, this one same as just now, so I don't want to discuss already. You all have to practice this by yourself. But what happened next is maybe sometimes they'll ask you about what the boiling point, melting point, the solubility, okay, the electrical conductivity. Okay, so this one is another type of question for your ionic and covalent. Okay, so let's say for boiling point, melting point, it's high because it's strong electrostatic force. For covalent, it's low because it's actually the force of attraction between molecule. And then you have your electrical conductivity. If you got positive and negative ion, then yes, it conducts electricity. But for covalent, don't even have a charge. No positive, no negative. So no charge. So you can say no free moving ion. So no, does not conduct electricity. And then going down, solubility in water, got positive, negative, yes, soluble in water. If neutral molecule, soluble in organic solvent, but not in water. Okay, so this will be the things we can see from here. So just go through here, guys. Make sure you do this yourself later. Okay, then going down, guys, because got other bonds, okay, because beside ionic, beside covalent, okay, we got other bond. Like what? Yeah, the next page here show you the other smaller bonds. Okay, for example, like say ethanol and ethane, guys. You see, ethane is only C and H, correct? So this one is covalent, because non-metal and non-metal. But for ethanol, got C, H, and O. Got the extra O, then you got one more new bond. It's not just covalent. Okay, covalent both also got. Ethanol got covalent, ethane also got covalent. But your ethanol got one more extra bond. We call it the hydrogen bond. So why is it called hydrogen bond? So guys, you see, a lot of heat energy. Okay, because hydrogen bond is only formed between who? Hydrogen bond is only appearing when your hydrogen bonded to oxygen, which is high electronegativity. Actually, not just O lah. Okay, to be exact, it's supposed to be NOF. The high electronegativity molecule is supposed to be nitrogen, oxygen, or fluorine. Okay, so these three, either one, when he bonded to your hydrogen, then yes, you can form a hydrogen bond. And because of the extra hydrogen bond, you need a lot of heat energy to actually go with your van der Waals attraction force and also to break your hydrogen bond. So if only covalent, you just have to break the weak van der Waals force. But if now you got covalent together with hydrogen, you got two things to break. Van der Waals with the hydrogen. So that's why ethanol, it's having a higher boiling point than ethane. So this is the third bonding learned in this chapter. And then going down, also got another, your ethanol is basically having hydrogen bonded to oxygen, which is high electronegativity. Okay, so you can form hydrogen bond. Okay, oxygen can form hydrogen bond with the atom. Okay, then it's soluble in water. So guys, you see, having extra hydrogen bond doesn't just make it higher melting, higher boiling point, also make it suddenly soluble in water. Because covalent is something we learn, covalent is actually insoluble in water, but sometimes some covalent compound can soluble in water because of the new hydrogen bond. So hydrogen bond got two extra info, can make it higher boiling point and also soluble in water. So this one is the two extra hint for hydrogen bond. Then going down, there is another bond where you see your H plus having 0 electron. Then your ammonia is having the extra lone pair of electron where your nitrogen is okay to share to your hydrogen ion without asking for any in return. Okay, because usually sharing is I share you one, you share me one. But for this kind of sharing, it's called a dative bond. What is the dative bond? Means one side share electron, but the other side don't contribute anything. So see, hydrogen ion does not have any electron in its shell, so where it will be having a lone pair of electron together with the hydrogen ion. So they share in this way. Okay, I share you two, but I never ask anything in return. Okay, so this share electron is a dative bond. Okay, so you must have the keyword lah. Okay, as long as you have to think this would call the lone pair of electron and then share to someone else that is not having any electron. So this is the dative bond. And the last bond, guys, you see, we got ionic covalent, got hydrogen bond, got dative bond. Last one is called the metallic bond. So metallic bond is, of course, in between metals. And then the type of bonding is metallic bond. But what is the explanation for metallic bond? I believe this one you all do before a lot. Okay, you see, it's basically having the valence electron of your metal atom can be easily donated and delocalized. So this one is actually the first keyword saying that we have delocalized electron. And then together, we got positively charged metal ions. And then all the delocalized electron can move freely within the metal structure to form an sea of electron or electron sea lah. Okay, up to you lah. So what is really metallic bond? Because always we say bonding is like attraction. So you must have two things attracting each other. So to be exact, metallic bond is the electrostatic attraction between your sea of electron and your positively metal ion, positively charged metal ion that gave you your metallic bond. So that will be the full explanation for metallic bond. Okay, and how does it conduct electricity? So of course, he can conduct electricity, like metal can conduct electricity, because they got the delocalized electron, which is a sea of electron. They can move freely and carry charges from negative terminal to the positive terminal and conduct electricity. Okay, so this is the 5 bonds we have in this chapter. So guys, you see, I go through all 5 bonds in very quick way because it's just question 2. Okay, hopefully that doesn't change the paper okay. So if this one come out in question 2, hopefully these 5 topics can get your full marks, okay, for your chemical bondings. So after chemical bondings, okay, we got the third question, cosmetic. Cosmetic, like I haven't taught this in our normal class, okay, even you are in maybe Utane's class or Wyland's class, okay. So this topic like we haven't teach because this one is your form 5 chapter 5. We haven't gone through this topic yet okay. So what actually happens here is, okay, it's all on memorization, guys. Legit no way to avoid for cosmetic. You must memorize, like, oh, you see the ingredient given here, okay, got moisturizer at supermarket, homemade moisturizer. So you got coconut oil, mercury, potassium carbonate, and then for homemade is like aloe vera gel. Okay. So of course they're gonna like compare. So what does it mean by cosmetic and what type of cosmetic used in moisturizer? So cosmetic definition, material and or product used externally to cleanse, protect, or enhance one's appearance. Okay. So and then they ask you what type of cosmetic, guys. Cosmetic got 3 types. Okay, got makeup cosmetic. Yeah, wait guys, my iPad be laggy. Okay, for those who, let me just show you the notes we have, guys. For those who have your notes with you, I mean, from chapter 5 lah, if you flip into your cosmetic topics, you'll see something like this. Okay. Page number 24. This one is your normal class chapter 5 notes. You see got all these ingredients. These are all the ingredients in your cosmetic. You see, this is the definition for cosmetic. And then we have 3 types of cosmetic, which is your makeup cosmetic, treatment cosmetic, and fragrances. So moisturizer is under the treatment cosmetic. For you to treat your face, ma. Moisturizer is not to beautify your face. You put moisturizer, you don't look better, okay? It makes your skin better. So we can say that inside here. Okay, one more answer. You can say this is a treatment cosmetic. Treatment cosmetic. Guys, whatever it miss out, okay, you all actually add in treatment cosmetic. So this one here. Plastic surgery. Plastic surgery is not a cosmetic though. Why go write plastic? Hi. Sorry. Cosmetic. Cosmetic. See, got affected by you already. You say plastic surgery, I go and say treatment plastic. Hi, yeah. Okay. Okay, so for moisturizer, okay, see from here, why? Okay, they say why is it safe to use the homemade moisturizer? Okay, use which moisturizer used by Pond City is better, like? Okay, so usually you say homemade is safer because using natural ingredient, okay, free from harmful chemical, okay, low cost. Okay, these are many answers, and you can also talk about the bad thing about the supermarket moisturizer. Inside got what? Got chemical. Got like special chemicals. They can cause you like kidney failure, nervous system problem, guys. This one mainly come from where? This problem come from having mercury. Okay, mercury. Mercury is a very toxic chemical. But it's very good for what? For whitening effect. Means if you apply this cream that contains mercury, it actually makes your skin become brighter. Okay, like you all like reflect light. Okay, so a lot of people say, I put this cream, my skin looks shiny, looks bright. It's mercury. Okay, so don't think too much. Okay, it's chemicals. So of course, this will be your moisturizer. And then going down, we have some cosmetic using your nanotechnology, guys. Because this topic after cosmetic is nanotechnology. So what's the advantage of nanotechnology? So able to coat the skin more evenly. Like you see, guys, you see nowadays all the makeup powder and stuff, right? They are all like very small particles, right? Those are nanotechnology. Okay. So able to penetrate the skin more easily. So these are all the small size particles benefit. And then mercury is widely used in cosmetic product. One side effect, guys, side effect for mercury, damage to your kidney, skin irritation and stuff. Yeah. State one application of nanotechnology used in semiconductor in your processor, your phone, your computer. Okay. So these are the keywords here. And then aspirin, this is under medicine. Okay, also it's around the same topic. We got medicine, we got cosmetic, and then got nanotechnology. Okay, so aspirin, okay, can use for relief pain. It's the same thing as Panadol, but it's actually more acidic. So it's more acidic, so it's very dangerous for gastric patient and also for kids. Okay, not suitable for kids. So they say, can you use for gastric patient? The answer is no, because it's acidic, or you can say it can cause internal bleeding. Okay, so it will cause like uh stomach ulcer, then causes your stomach to be bleeding. So this will be the medicine set. Okay. Going down, guys, after cosmetic nanotechnology, okay, we got alloy. So alloy, like guys, so from here, you see, we have I give you few questions. One question is based on experiment. So where we have copper and bronze. Copper is pure metal, then bronze is what, guys? That's your bit first. What is bronze? Whether you all know what is bronze or not. Because here, copper is pure metal. Bronze is what? Bronze is what plus what? What alloy is this? Because got two alloy come from copper. One is bronze, one is brass. So just in case you all forgot, bronze is copper and tin. Okay, then got the other one is brass. Brass is copper and zinc. Okay, make sure you all know this just in case. Okay, then as you all know, we know alloy is harder and stronger, ma. So that's why when you actually drop this weight, hit the ball, and the ball will create a dent. The dent supposed to be smaller for your alloy. Why like harder, ma? Harder means hard, like harder to actually hit through, ma. So when you hit the ball and create a diameter, so you're supposed to say that the alloy give you a smaller diameter. But of course they're gonna ask you explain lah. Okay, why bronze smaller diameter? So because you say that copper, okay, inside is pure metal ma. So it's a same size atom which are orderly arranged and easily slide when force are applied. But in the other hand, your bronze is actually your alloy with different particle size. So you can say that consists of tin, which is foreign atom which disturb, or usually we use the word disrupt also can lah. Disrupt. Okay, the orderly arrangement and make the copper atom layer harder to slide when force is applied. Okay, so this is the pure metal and the alloy explanation. Okay, after alloy, we got glass. Guys, glass we got four type. We got the basic one, uh, fused glass, and then we got soda lime glass, we got borosilicate glass, and then we also got the crystal lead crystal glass. Okay, so we got four type of glass. So what happened here is, you see, they say it shows a cracked glass when Ahmad pour hot coffee drink into early in the morning at Cameron Highland. Means outside very cold, then suddenly hot drink go in, hot and cold at the same time. So something gonna crack. Okay, so if your glass cannot withstand like temperature change in a sudden go in this way, you see, I mean, like your temperatures like suddenly hot, suddenly cold, then your glass crack. Usually this one is your soda lime glass. Okay, because soda lime, the benefit for soda lime is like you can actually have a like low temperature, then you can melt it, and then you can like mold it into different shape. So that's why a lot of stuff around you made from soda lime glass is to make like into different design, like your light bulb. Okay, we use soda lime glass, but soda lime is not meant for suddenly hot and suddenly cold. Suddenly hot and cold, the way is for borosilicate. Okay, that's why we use borosilicate for what? For test tube, for boiling tube. Okay, so soda lime has high thermal expansion coefficient and cannot withstand sudden temperature change. Okay, guys, just in case you all didn't know what is this, high thermal expansion coefficient means that he expand a lot when heated and contract a lot when cool. So that's why you see, you pour hot water, he expand a lot. Then if you actually pour cold water, he contract a lot. So the contraction, the movement of particles too big movement already, it will causes a crack. Okay, so this is the concept for soda lime glass lah. So what is a substitute for this? We're gonna use a borosilicate glass, has zero thermal coefficient, expansion coefficient, means hot water, cold water doesn't expand, doesn't contract. So it's resistant to thermal stress. Can all good Okay, then of course, guys, after alloy, after glass, okay, we got other topics like we got ceramic, we got composite material, but not seems like it's not inside your tips, okay? But guys, don't skip lah. So ceramic knife made from advanced ceramic. So this is the keyword here. What is an advanced ceramic? So advanced ceramic means you take ceramic, but you add stuff. So what you add? Okay, you add such as oxide, carbide, and nitride into your ceramic. Okay, something like alloy lah. Alloy you add like different metal ma. So ceramic, advanced ceramic means you take ceramic, you add other chemicals, like say oxide, carbide, nitride. And two application of advanced ceramic. So we use it in semiconductor, okay, heat insulator, which can withstand high heat. Okay, so this will be uh your advanced ceramic. Usually we also use it in your brake disc. Guys, you know your car brake disc are also to for withstand high temperature, okay, high heat. Then going down, why aircraft body are made from duralumin, guys, just in case you didn't know. Duralumin is the alloy of aluminium. Okay, so of course, why we use actually duralumin instead of pure aluminium? Guys, if you all know aluminium foil, so soft. Can you use it for your aircraft? Cannot, okay? So we want it to be light and strong. Pure aluminium is soft and light, but not strong. So we actually add in copper, manganese, magnesium, so three other different metals, and then they will actually make it harder and stronger, yet maintain its low density. Oh, there's a missing word here, low density. Okay, can So of course, guys, the next page is also say similar question, also on the glass, okay, also on your composite material, your alloy. Okay, so guys, next page, I'll just leave it for your own practice. Okay, you'll just do it later. Okay, after alloy, after glass, after your chapter 8 of your form 4, then we got transition element. So transition element is also one of the easy topic we have in our syllabus. Okay, so we can see these are all the elements given. Okay, all the X, Y, Z, A, B, C, D, E. Okay, so most likely they will ask you the position of your element. So I have to explain what group is it, what period is it. So let's say for B, okay, so for B is here, okay, so B is 1, 2, 3. It's the third column, so we say it's a group 13. Don't give me group 3. Okay, the column decides your group, but then if it's group 1, group 2, then this one is group 13. Because 3 to 12 is your transition element. Okay, so the actually group 13 because it has 3 valence electron. Then you see it's at first row, second row, third row. So guys, the rows decides your period. So when we say period 3 has 3 shells occupied with electron, guys, this one must write the full thing. You cannot say 3 shell. No, then no more already. No, you must say 3 shell occupied with electron. Okay, and then there are some elements given here. Yeah, so uh most likely guys, I show you the transition element one. Yeah, color compound, then you see G, transition element. Okay, act as catalyst, you see G again, transition element. Okay, so the rest guys, it's your group 1, group 17, group 18, and also your period 3 information. So guys, this chapter, like chapter 4 in your form 4, got 5 topics. Got group 1, group 17, group 18, and then period 3 and transition element. Okay, so got 5 topics around overall. Then of course, write out arrangement, arrange in according in increasing the atomic size. Okay. Okay, guys, talking about size. Okay, maybe you all, because this is a lot also quite a common question that students get it wrong. If you compare size, among the same group, actually very easy. Why? Because 1 shell, 2 shell, 3 shell, and then 4 shell. So I believe in the same group, the size to see is actually very easy. But among the same period means like if I go through like BDE, okay, in the same row, supposedly everyone here got 3 shell. But are they the same or different size? You have to know. From left to right of your periodic table, the proton number increase. You have to know from left to right, proton increase. So if proton increase, he got more force, he got more attraction force to pull the electron outside closer towards the nucleus, because proton inside nucleus, then electron outside nucleus. So if your proton increase, it's like having more magnet. You can pull your electron closer towards the nucleus, becoming smaller in size. Means if I draw out BDE, BDE will be 3 shell. Okay, D also 3 shell, but it's closer towards nucleus. Then E also 3 shell, and it's even closer towards the nucleus. So means that everyone in the same period is actually same shell, same number of shell, but size getting smaller. From left to right lah. Size getting smaller from left to right. So therefore, it's because of what? Because of increasing proton number. All good. Okay, guys. So is that okay? This is a brief go through on this chapter. Okay, special characteristic of your transition element. Okay, so you can see act as catalyst, color compound, complex ion, more than one oxidation number. Okay, you can say different oxidation number. So is that okay? Then next one is rusting. Guys. So I give you 2 questions. One is based on the water droplet. The other one is on the iron nail. Okay. So guys, I discuss briefly one. So for the water droplet type of question, you must remember where is your anode, where is your cathode, where you lose electron, where you gain electron. All started off from the center where your iron lose electron. You see, at the center of the water droplet, okay, which is the anode, iron ionized to form iron to ion. So the equation will be Fe become Fe2 plus oxidation. Okay, and then the electron will go where? You see, electron, when you lose electron here, he'll go to the edge of the water droplet. He'll go to the side of the water droplet, where on the side of water droplet, you got 3 things. Number 1, you got oxygen. Number two, we got water. Number three, you got electron. So got water, got oxygen, got electron, got all three together. You're going to combine to form your hydroxide ion. So you see, water, oxygen, receive electron to form OH minus hydroxide ion. And this is reduction. So that's why this topic, this rusting is under chapter 1, your redox reaction. Can? So the two ions that we form here is Fe2 plus and OH minus. So therefore, they will combine to form a green precipitate, the FeOH2. Okay. Then it will further oxidize, means that you will continue oxidize by air. So for to actually form green precipitate, continuous oxidation with oxygen to form a hydrated iron 3 oxide. So this will be the equation given. Okay. So guys, hopefully you all have a clearer idea on what is your rusting, okay? Can okay, then after the basic rusting, sometimes they will ask you like, if I put different metal together, can your different metal protect your iron from rusting? So you have to check lah, according to reactivity series. Okay, so of course, wait, my iPad be lagging. Guys, am I lagging? Because I feel like my screen a bit lagging. Oh, it's back, it's back. Okay, just now was lagging. Eh, my human is lagging, is it? Just now, now okay. Okay, now okay, good. Okay, yeah. So of course, if you see from here, you can see metal X and metal Y. So what happened is, you see, if it's scratch, water goes in, scratch, water goes in. But they say, iron with X did not rust. But then iron plated with Y rusted. So means what? Means X never protect your iron from rusting, while Y protected your iron from rusting. Okay. So means I will say that X must be actually less electropositive than an iron. Then rust, if you can actually, if your Y managed to protect your iron from rusting, means that Y rusted first. So the one that rusted first is more electropositive. So who is more and less electropositive than the iron? Remember your reactivity series. Usually, if you go with the list, guys, you see, is okay. The list go in this way, similar something like this, So it's kalau nak kahwin mesti ada zakat fleksibel supaya perempuan hasil cukup anak. Okay, something like that lah, guys. I believe you have your own way to go through. Okay, so if you see iron is here, iron Fe. Okay, so I want something above Fe, can be zinc, aluminium, magnesium, these three lah. So you see from here, my X can be magnesium. So of course I can slash lah. Can be zinc, can be aluminium. Okay. Then for your Y, wait. Guys, I think the answer a bit terbalik. Wait. I think this is Y. This is X. Wait, let me double check. X did not rust when the coating of iron plated with. Oh, guys, I read too fast, guys. I read too fast already. They say iron plated with X did not rust. Not the X did not rust. Guys, don't be like me. Yeah, guys, I read too fast. Okay, my bad. Okay, so is the iron plated with X did not rust. Yeah. Then iron plated with Y rusted. Hiya. Okay, so means that X actually, yes, protected iron from rusting. So magnesium, zinc, aluminum, correct. Then Y did not protect iron from rusting, means Y with iron, iron still rust. So we'll be going with lead. Okay, so means below Fe got what? Got tin, got lead, got copper, got silver. Okay, maybe got copper is one of a common one also lah. Copper, okay, copper and lead that will make your iron rust. Okay, so the explanation will be more electropositive, corrode first, okay, while iron is more electropositive than lead, so iron will corrode first. So rusting occur. Okay, so guys, so this one is just a go through on your comparison of your metal rusting. Can Then the next stage, guys, is also the similar thing. Okay, so who can protect who from rusting, but it's on iron nail lah, instead of like just like this. Okay, so same concept. See who is more electropositive, see who is less electropositive. Okay, so I'll leave this for you guys to do it yourself. Okay, so moving on. Yeah, moving on. It's your carbon compound. Guys, this one is also one of my chapter that I'm very worried about you guys. Okay, that you all actually the nightmare. Of course, nightmare. Okay, so guys, this chapter a lot of stuff. Okay, got what? Alkane, alkene, alkyne, and then got alcohol, carboxylic acid, got ester, got so many things, and then got so many information to memorize. Where I just gonna only go through a brief one with you lah. I cannot go through so many things in this short time. So what I can say is here. Okay, do you see that compound S? Okay, you put your R, become ethyl propanoate. Guys, according to the name, I think this one you very familiar. Ethyl propanoate, what is this? Ester. Okay, why? Because only ester, the name will be so special. One got two part, got ethyl propanoate. Okay, and then ethanoic acid. Okay, I think this is a carboxylic acid. This one, okay, carboxylic acid. Okay, and then so what happened is here, your S can put Q become acid, can put R become ester. So think about a chemical, a category where can become ester, can also become acid. So if you think about it, since we say that S can become acid, correct or not? So can S itself be acid? No ma, correct. So if you think about it, the other side, how do we form ester? Ester is alcohol mixed with carboxylic acid, then only you form ester ma. Correct. So if I told you S mixed with Q can form ethanoic acid, it means that S is not an acid. So if S is not an acid, what can be your S? Only the alcohol. See, you try to combine the two information. So since we know like this S must be alcohol. And then your alcohol, can he become alkene? Can. So alcohol can do many things. Okay, alcohol can become acid. Alcohol can become ester. Alcohol can become alkene. Okay. So first, guys, I think that's alkene. In given here alkene. Okay. So hopefully with this information, let's try our question. So what is process P? Okay, so from alcohol to become alkene. Okay, so what's a special part for alcohol? Is the OH. While for alkene, is the double bond. So he loses the OH and also H. So he loses water. So for this part is here, S to ethene is actually remove H2O, remove water. Okay, so we call it dehydration. And the name for S will be ethanol. Why ethanol? How I know it's ethanol? Because you see, very simple. S become ethene. S become ethanoic acid. So both product you form from S, they are both ETH, 2 carbon. So I will say S is also come from 2 carbon. So it will be ethanol. Okay, so this part here is ethanol. And then molecular formula C2H5OH. Guys, memorize, refresh a little bit. What are the general formula? Guys, hopefully you all got revise. Guys. I know you all have been through BM, BI, sejarah, physics. Okay, yesterday got physics extra class, right? Now you see for chemistry general formula for all the topics we have. Okay, so we got alkane. Oh guys, by the way, this one is called what? Homologous series. So if the question asks you homologous series, make sure you know homologous series is the general term, the group name, the family name. So homologous series right here is it alkane, alkene. Okay, alkyne I don't go through because alkyne is very low chance. Alcohol, carboxylic acid, and then your ester. So guys, what is the general formula for alkane? CnH2n plus 2, where your N start from 1, 2, 3, and so on. For alkene, CnH2n, guys, if you don't remember this, please write this down. CnH2n, okay, N start from 2, 3, 4, and so on. Okay. Then alcohol, it's together from an alkene, but you add on water. So CnH2n plus 1 OH, your N starts from 1, 2, 3, and so on. For acid, CnH2n plus 1 COOH, but your N starts from 0, 1, 2. Okay, so these are the carboxylic acid got COH, correct? Okay, but be careful on that because you already got one C at the back. Okay, for carboxylic acid, already got one carbon at the back. That's why your N in the front start from 0. Okay, so it means if you say ethanoic acid, ethanoic acid is, I will put my N equals to 1. Even though ethanoic acid is 2C, but at the back already got 1, so I just need to put one more in the front. Okay, be careful on using this formula. I don't want you all see ethanoic acid, then you all go like 2, then you got 3 in total. Wrong already lah. Do you have methanoic acid? Got, means your N equals to 0. If you put your N equals to 0, here your C is 0, and then here you get 0 plus 1, so it's actually HCOOH. This is the formula for methanoic acid. Okay, okay, then for ester, ester is technically taking your alcohol and acid combined together, but you have to remove water. So how do you remove water? Okay, something like this. I rewrite my ethanoic acid formula, COH okay. Then my alcohol is like this, CnH2n plus 1 OH. So okay, what I do is I will shift my OH to the left side, that is OH. So do you see I put my OH to my left side of my formula? Why? Because it is easy to see. So what you do is you take out water, means you take out H and OH. You see guys, again, you all see my removing part. I take away H from alcohol, OH from acid, then I combine them. This is your general formula. And this is also how you draw, how you write your general formula for your ester. Okay? So when you take out water, you're going to form something like this, okay? But usually, guys, for general formula, because your acid and alcohol can be different carbon, so we're going to substitute your N with another unknown. We put it with M. Okay? So why got M and N? Because to indicate two side can be different carbon, means front can be 5, back can be 2, okay, up to you, okay? So up to the question lah. So this is all the general formula, and the N start from what? It follow your alcohol and acid lah. Start from 1, 2, 3. This one, acid start from 0, 1, 2. Then your M is our alcohol, start from 1, 2, 3. Okay, and also guys, since I give you this already, I give you more lah. Okay, what is the next thing is they like to ask you functional group. What is functional group? Of alkane is the carbon-carbon single bond. Okay, we call this the single bond. Okay, then for alkene is the double bond. The special part for alkene is double bond. Then the special part for alcohol is the OH. Usually we call this the hydroxyl. Then for acid is the COOH. It's called the carboxyl. While the last one is the COO. Okay, the ester is called the carboxylate. So we got homologous series, we got general formula, we got functional group. Okay, so hopefully this one brings back some memories on your chapter 2 啦。少一个 alkyne 对 so I never put in alkyne here because alkyne actually very similar to alkene. Technically alkyne, okay guys, since someone asked about alkyne, I give you alkyne also lah. Alkyne is CnH2n minus 2. Okay, then your N is 2, 3, 4, and so on. Then the special part is the triple bond. Okay, this is alkyne. But I never put alkyne because alkyne very low chance. They rather ask you alkene. In alkyne and alkene, if they want to ask alkyne, they might as well ask you alkene because alkene got more thing to ask. Okay, so that's why I never put in alkyne lah. Very, very low chance one. But never mind lah, since it's here already, I just give you all lah. Ester very hard, of course. It's one of the last topic of this chapter Okay, so So guys, you see, so if I go through a quick one, okay, so for your alcohol, okay, process of P is to remove water mah. So alcohol, you take out the H and OH, okay, which is take out OH, okay, you take out one more H from the H5, okay, then become C2H4, and the H2O comes out separately. Can Then they say S and ethanol acid come from different homologous series. What's homologous series? Choose from here. So S is alcohol, ethanol acid is carboxylic acid. I see. Guys, you see, with this better already, yeah. Functional group for S and ethanol acid, alcohol is hydroxyl, acid is carboxyl. Okay. And the reagent used for process Q, guys. What is process Q first? How alcohol become acid? Like I told you all last time, how your alcohol become vinegar. Because ethanol acid is vinegar, okay. So how alcohol becomes sour taste means your alcohol, you drink halfway, then you don't drink it, you forgot to close tightly. You forgot to close your alcohol tightly, means that the oxygen around the air oxidizes your alcohol, then he will become acid. So means guys, if you want to get slapped by your father, you find your father's very exclusive, like those wine around the house, you open up, let it expose to air, and then become acid. Then your father gonna slap you. Okay. So of course no lah. Okay. So of course, this one you call what? Oxidation. So if you want to like make your oxidation faster, we're gonna put in oxidizing agent. What is the common oxidizing agent we learned in chapter 1? Acidified potassium manganate 7, acidified potassium dichromate 6. So from here, okay, we actually put in your acidified potassium manganate 7 because this is your oxidizing agent. Oxidizing agent. Okay, and then color purple to colorless, hopefully you all remember. Okay, and then the equation of acid and metal, guys, just try to remember, like HCl plus magnesium. Okay, you displace off the Mg, Mg displace off the H, become Mg Cl2 plus H2. Okay, so this is a normal equation with acid and metal. So you just try to imagine that your Cl right now is your CH3COO, CH3COO. Okay. Instead of having a simple positive and negative ion, actually CH3COOH is a positive ion at the back and negative ion in the front. So means this is a negative ion. So treat this as like your Cl minus. You take away the H, put in Mg to him, then he become this chemical. Okay. Okay. And then they say in the process of R, M, and catalyst L are mixed with compound S to produce ethyl propanoate. Guys, what is the process to produce ester? Esterification. Okay, and name your chemical M and your catalyst L. So M is propanoic acid. Why? Because if you go back up, since we said that your S is ethanol, and that decides your ethyl, then who decides your propanoate? Your R. So R must be 3 carbon. So 3 carbon acid is propanoic acid. And what is a mix with compound S to produce from here? We can say we mix with concentrated sulfuric acid. Okay. Characteristic of ester, fruity smell, pleasant smell. Okay, all good. And then draw the structure of ethyl propanoate. Guys, this one same like the formula just now. Just now I say, if I draw out acid and alcohol first, you see, if I draw out propanoic acid, it's something like this. There's 3 carbon with a COOH, okay? Then plus your ethanol. Okay, ethanol had this C2, but I put my OH on the left. Why put my OH on the left? Because how do I want to combine them? Take away H, take away OH. You see, so if I take away these two things, I take away this, then you combine them. This is your ester. Which is actually the same drawing. But I never put in the H lah. Okay, guys, this and this you see is the same. CO in the middle. Okay, 3 carbon on the left, 2 carbon on the right. Same. So how you form ester? Draw your acid, draw your alcohol, take out H and OH, combine. That is your ester. Same thing how you form your general formula. You do the same thing on how you draw your ester. Okay, can And guys, there are more questions about your chapter 2 here. I'm just gonna give it, let you all do yourself. Okay, got more tests lah. Got the bromine test, and then got the combustion test. Okay, so this one leave it. Okay, I got more questions lah, guys. I put in more questions for carbon compound because it's a nightmare. Okay, okay. After that, it's your synthetic. Okay, synthetic. We call it the polymer. Yeah, okay, because the tips only say got synthetic rubber. But I also put in natural rubber lah, just in case. Okay. So we got natural rubber, and then you see natural rubber can actually turn into your solid form. Okay, by adding X. It can also remains a liquid latex by adding solution Y. Okay. But then you see X can become Z. Okay. So becomes your vulcanized rubber. So what is process Z? Vulcanization, where you add in sulfur for crosslink. Okay, for the sulfur crosslink, okay, make it harder to slide over each other. Okay, harder for rubber polymers to slide over. And then, okay, what do we do for here, guys? When we see your rubber, your latex, can actually become solid or can remain liquid. This one is called what? We call it the coagulation of your latex. So how do you enhance coagulation? How do you make coagulation faster? So we add in acid. Okay, why leh? Because acid got what? Got the hydrogen ion to neutralize the negative charge on the protein membrane of rubber. Then they will collide with each other, break the membrane, and then free to coagulate. Amino acid amino acid cannot. Okay, this acid can be any acid. Okay, can be lactic acid. But don't give me strong acid. Weak acid is better because strong acid might corrode your rubber, your latex. Then of course, solution Y can prevent it from coagulation. We add alkaline, the opposite of acid. So why then he contain hydroxide, and hydroxide will maintain the negative charge on the protein membrane and do not coagulate. Okay, so guys, in this case, this one is natural rubber. Just a brief go through. Got vulcanization, got your coagulation. But what is next is really the tips one is the synthetic rubber. Synthetic rubber got many types. Okay, so mostly I give you this table, guys. See this table. We got 5 types: neoprene, thiocol, nitrile rubber, silicone rubber, and SPR. Memorize. Nothing much here, guys. Synthetic rubber is all memorized. So this one just a brief go through. Okay. Not gonna go in details inside here. Okay, then next one, guys, is finally entering. Okay, according to the tips, the tips here is starting from this, question number 17, is your essay. Because it's question 9, 10, 11, So here is essay in your tips. Okay. In your tips says this is essay. Tips say not essay tips say Okay. So here is your heat of neutralization or heat of precipitation or heat of what we say the heat of displacement. So I give you 3 heat okay. Definitely don't have combustion according to tips. Okay. So got definition and then got calculation. Okay. Got calculation and then got precaution. Okay, so make sure you all have your precaution. So, but guys, I think this one are very, very common. I mean, you're all very fresh on this because you all actually do this in your Amali kind of. I think when you all do Amali, you all study this topic a lot. Okay, so you all know that this whole topic stick to 3 parts, which is your definition, calculation, and then your precaution. Like you use like polystyrene cup for what? Reduce heat loss to surrounding. Okay, and then of course don't forget your energy level diagram. Okay, so you see I will give you one of it is like this, guys. You see one important thing is you all go to page number 20. This one the heat of neutralization. Okay, the neutralization type of reaction exothermic is have to go with this. Okay, explain the difference of heat of neutralization for reaction 1 and reaction 2. Okay, you see reaction 1 and 2 is both same alkaline but different acid, then you get different heat of neutralization. Guys, what is the only reason that your heat of neutralization will actually change your delta H? Guys, remember your concentration, your monoprotic, diprotic, all these don't affect. The only thing is your strong and weak acid. Okay, the strength of acid affects your heat of neutralization. So if you say, if you have a larger heat release, it's a strong acid. ionizes completely in water, where weak acid ionizes partially in water. So some of the heat released during neutralization is used to ionize the HT, which is the weak acid, completely in water, so that you have lesser heat release. Okay. So why strong acid, strong alkaline got more heat? Because like they all already ion ma. So already ion means that they easily have reaction, they give out the maximum energy. But weak acid still got many part is molecule. I need to take a bit of energy, help him to ionize. Then the heat go out lesser. Because I use some of the heat to help the weak acid. Okay, so hopefully if they really come out heat of neutralization, this is something possible. Okay, and the rest guys is calculation. Okay, so guys, I don't want to go for calculation because calculation is very common, okay, in your previous exam, okay, also in your Amali and stuff. Okay, so you all studied this through already. So you see you got number of mole, okay, number of mole, and then got your Q equals to MC theta, and then we got your delta H. So many things from here lah. So guys, so this topic, this heat, I actually never plan to go in details on. Okay, I just put in so that you all do it yourself. Yeah, heat, this one not important for now, because not to say not important, because you all very fresh on this. I want to go for something that you all not so fresh. Okay, so if you go for the next topic, is after heat we have rate of reaction. Rate of reaction, the last two essay, question 10, question 11, one is rate of reaction, one is your standard solution preparation. Okay, so rate of reaction, I think is something quite easy, because you need to know the some of the definition. Okay, and then your curve one, why is it? How do you understand your graph, your curve? You have to understand the gradient and also the y-axis, the volume of gas produced. So what decides your volume of gas? Basically, your limiting agent, okay, your limiting reagent, and then your reaction will stop when one of the chemical finish. So when your chemical finish, the gas stop producing, so the height of the graph is the same. Okay. But guys, in rate of reaction, if rate of reaction in your essay, please, collision theory, confirm got. Okay, if rate of reaction is in your essay, please master off your collision theory for the different factor. Okay, so what collision theory we have? Temperature, concentration, size of your reactant, and also catalyst. Okay, so let's say for here, you see, compare A and B ma. So if you say A and B, A and B, okay, volume, total volume is the same, because see, acid 50, and then water 350 ma. B is 400 and 0 water. Means B got more acid. It means that concentration is higher. Okay, so A is like, oh, many water but little acid ma. Means it's diluted acid. So according to this theory, we know that this is about concentration. So what is the keyword for concentration collision theory? When you say concentration is higher, the next keyword is the number of hydrogen ion per unit volume. Guys, must include the word per unit volume. Never include this, no mark. Okay. So concentration means in the same amount of volume, you got more particle. Means right now is concentration of acid, you got more H plus. So when you have more H plus, frequency of collision, I see the keyword here, frequency of collision between hydrogen ion and magnesium atom is higher, for B is higher than A lah. Then frequency of effective collision between hydrogen ion and magnesium atom is also higher. Okay, and then eventually rate of reaction of B is higher than A. Okay. Jill, can you repeat how many collision theory? Oh, the 4 factors: concentration, temperature, size of reactant, and catalyst. Okay, the 4 topics, the 4 factors we learned before. All these 4 can have different collision theory. Okay, so this one is one of the sample ma. Okay, then you see, this one is concentration ma. The next question I give you is size. I see. Yeah, next one. The next question is where you see you put in 3 grams of marble granule and marble powder. So different experiment, different size of reactant. Do you see concentration same, volume same, mass is the same, everything same, only the size is different. So if it's size, what is your collision theory? So when size is smaller, total surface area exposed, guys, you must say your surface area of your chemical, your powder, exposed to your solvent, which is right now is your acid. is bigger. You got bigger or larger total surface area, then frequency of collision higher, frequency of effective collision is higher. So the last two sentences is actually same. But guys, don't forget, you in exam you must write between who and who. Okay just now previous one was what? Was frequency of collision between hydrogen ion and magnesium atom, because this is basically a reaction between the acid and the magnesium ribbon mah. So you always have to say collision between what particles. Okay, you don't go to exam just write frequency of collision increase, no mark. Frequency of effective collision increase, also no mark. Okay, so please be aware on that. Okay, careful on this. Okay, then see guys, collision theory, this is for size lah. Okay, and then probably they're gonna ask you to sketch also. Okay, so how to sketch? First of all, gradient. Guys, see for your graph for sketching graph, gradient is decided by your rate of reaction. That's why gradient definitely always different one, because different reaction, different rate of reaction mah. Okay, different speed. Can but your height of the graph means the maximum of the graph is decided by your number of mole. Why decided by number of mole? Because it's decided by your chemical. Yeah, one of your chemical finish, then your reaction gonna stop going up anymore. Okay, so this one is the two information. Before you sketch your graph, check your experiment 1 and experiment 2. Do they have the same or different rate of reaction? And do they have the same or different height? That decides your gradient and height of the graph. Okay, and guys, those calculation I'm not gonna do it because it's just a simple one. How to calculate rate of reaction? Volume over time. Volume over time. Okay, same volume but different time. Okay, nah? Okay. So this one I just leave it for you guys. Can? And then I will give you more. Next one is the collision theory for temperature. The temperature. So when temperature is higher, higher temperature causes your particles to gain kinetic energy and move faster. Then they are able to achieve activation energy. Guys, got two collision theory involve the words of using activation energy. One is temperature, the other one is catalyst. Okay, so when you have more energy, they are more able to actually achieve the activation energy. Then the last two answer is the same. Frequency of collision increase, frequency of effective collision increase. Okay, so guys, you see collision theory overall is only the first few sentences is different. The conclusion is the same. Okay, so beware on the keyword on the first few sentence explanation. Okay, concentration, temperature, size of reactant. Okay, and one more here is okay, I got more question lah guys, so basically you can go through it. Okay, one more is the catalyst, right? I purposely put all four one. Okay, you go for next page, you see this one. You see set 1 and set 3 okay, set 1 set 3 is like this. Okay, set 1 and set 3. Okay, same acid, same volume, everything same, but set 3 got add 5 cm cube of CuSO4. If everything is the same, but if one of the reaction got add something extra, that must be your catalyst. Okay, so what is the catalyst collision theory? So the presence of catalyst, okay, provides a shortcut alternative pathway with lower activation energy. So more colliding particles able to achieve the lower activation energy. Frequency of effective collision is higher, rate of reaction is higher. Guys, do you see catalyst? You mentioned the word more particles can achieve lower activation energy. Then you straight away go for effective collision. Do you realize this, the catalyst one, you don't mention frequency of the normal one. Frequency of collision, we never say. Because colliding particles, when they achieve the lower activation energy, all of the collision is effective collision. Okay. So catalyst got one sentence lesser. Okay, catalyst one usually is 5 sentences Catalyst only got 4 sentences. Okay, so this is the main difference. So guys, I highlighted all the top four factors. So size of reactant, temperature, concentration, catalyst, all 4 got. Okay, so later you all try to write out this by yourself. Okay, so after your rate of reaction, finally guys, the last question that you cannot avoid is your question 11. Okay, the essay that you cannot avoid must do. Okay, what according to tips is to say is the role of water. So why we have to, when we learn role of water, I see, let's say for here, I have hydrogen chloride gas. They are both HCl, but they're not acid yet because you all know HCl is hydrochloric acid. But hydrogen chloride gas is not an acid yet because it is a gas molecule without water. So what we do is we put into different solvent. We got two different solvent in our syllabus. We got universal solvent, which is water. We got organic solvent, which is the opposite of water. Usually it's oil, other stuff lah. So okay, so if you put in solvent K, your pH is 7. Your reaction with calcium carbonate no change. It means what? Means that HCl in this case cannot have acidic properties. You see, pH never change. No reaction with carbonate because acid with carbonate usually got carbon dioxide one ma. So that's why first one is not showing acidic properties. But second one, you see pH is 1 and then lime water turns cloudy. All this is the proof of showing that now your HCl in this case is showing acidic properties. So what is these two solvent? K is methylbenzene, L is water. So guys, what is K? Usually is any sample of organic solvent. So got many answers lah. Got methylbenzene, trichloroethane, okay, and then got propanol, okay. So you can go with methylbenzene. This one is the common one that you all see, okay. So if you want one more, you can say propanon. Propanon. Okay, and what's the reason for that? Because for methylbenzene, for propanol, for organic solvent, they cannot use the word ionize. They never ionize. So you see, in methylbenzene, your hydrogen chloride does not ionize and remain as neutral molecule. If no H plus, if there is no H plus to acidic, to show you acidic properties, exhibit means shows, and does not react with calcium carbonate. So this is just organic solvent explanation. But when we go into the next one, when hydrogen chloride is dissolved in water, it ionizes to form hydrogen ion and chloride ion. This causes the acidity with a pH value of 1. And at the same time, this H plus will react with your carbonate and forms your carbon dioxide. So you react with calcium carbonate to produce carbon dioxide, which turns your lime water cloudy with this equation given. Okay now. So guys, do you realize this topic is about the importance of water? No water, no acidic properties. Got water, then got acidic properties. But we got explanation about it. Why? Because acid only ionize in water to show you the H plus. And then only you get more reaction, you get acidic properties and stuff. Can then okay, so guys, hopefully all this is what we learned before. Okay, more gas bubbles are released when other acids used. So name another acid that can give you more gas bubble. So means if you want more CO2, I need to think about an acid that got more H plus, because more H plus means more CO2 ma. So we think about sulfuric acid because it's a diprotic acid that give you 2 more of H plus. Because hydrochloric acid only got 1 H plus ma, but sulfuric acid got 2 H plus. Okay. So not just acid need water, alkaline also need water. You see, ammonia in chloroform, ammonia in water. Why is it chloroform? No change. In water, red litmus paper turns blue, guys. Water again. So ammonia exists as neutral molecule in chloroform, no hydroxide. So that's why it's not alkaline. Okay. While ammonia ionizes partially in water to give you low concentration of hydroxide. Never mind. As long got hydroxide, it will turn your red litmus paper blue, and this is your equation. Okay, the NH3 plus water, you form ammonium ion and hydroxide ion. So this is the ion that shows you your alkaline properties. So this is a role of water for your acid and alkaline. Okay, not just acid, guys. Alkaline also need water. Okay, so guys, this one is your role of water. And then I give you more questions about your electrical conductivity. Okay, the one in water can conduct electricity. The one in organic solvent cannot conduct electricity. Okay, so this one extra question you all can try later on. Okay, and then the last one. Guys, the last one. Yeah. A student is required to prepare a standard solution. Guys, the definition for standard solution: a solution with a known concentration. Okay, or you can say a solution with your concentration is accurately known. Okay, so this one is another way of writing lah, but it's the same meaning, okay? And that means you know the exact concentration of this specific solution. We call it a standard solution. Okay? And the molarity, what's molarity? The number of mole dissolved in 1 dm cube of solution. That's why molarity unit is always mole per dm cube. So it's the how many mole in 1 dm cube of solution. Okay, and then there are some calculation go through. Okay, I just want to go through the theory lah. Calculation you all try yourself. Okay, so if the measuring cylinder, if explain if a measuring cylinder is suitable to be used to measure volume of water in the preparation of standard solution, guys. If you remember, measuring cylinder for measuring is not very accurate, even though it's called measuring cylinder, but it's not that accurate as you think. Okay, so it's not suitable. Okay, because it cannot measure volume of water accurately. And what is the best alternative for measuring volume? Volumetric flask. Okay. So measuring cylinder is for you to like do quick reaction. But if you want to prepare a standard solution cannot do it fast one, guys. Standard solution must slow and steady because every step is very important. If one step you miss out, you pour one drip lesser, one drop lesser, then your concentration is affected. So everything must be very accurate. Okay. And the two parameters to measure accurately before you prepare a standard solution are the mass of a solid, the volume of your water. Okay, so this is the thing that you need to know very accurately before you start your standard solution preparation. Okay, so how do you do your standard solution preparation? Very simple. You add your water carefully so that the level of solution does not exceed the graduation mark. Or sometimes you can say this word is called calibration mark. Okay, two different names lah, different depends on question. Okay, so once your level hits the calibration mark, okay, the volumetric flask is stopped. Stopped means you close it with a stopper, and then prevent the evaporation of water can change the concentration on of your solution. So you have always keep your standard solution in a volumetric flask with a stopper closing it. Okay, because you don't want it to evaporate, then you become not standard solution. Okay, so guys, this one is all just simple short questions. What I have at the back as the last question is your essay writing. Because guys, from the tips I see, if your tips is really accurate, you need to write procedure. Okay, you need to write procedure. Okay, so what you're gonna do, so right here, what happened is, you see, we started off with solid sodium carbonate and distilled water. Okay, what you need to do, use your calculation to find out how much of powder of this solid carbonate, solid sodium carbonate, that you actually need to prepare your standard solution. So you start from calculating number of mole, start from calculating mass. Once you know the mass, then you can actually start your procedure. You have to weigh exactly 5.3 gram of your solid sodium carbonate, okay, in a beaker. Add your water, stir the mixture with a glass rod until the solid is completely dissolved. Okay, but the water you add not enough one, and then you don't have to measure a specific volume. Let's say, teacher, since the exam want us to prepare 250 cm cube, do we measure 250 cm cube? No need, because you already got volumetric flask. Volumetric flask, the line is very accurate. So all you need to do is the starting part is just let the powder dissolve. Okay, just like making Milo. Just to dissolve the powder first, then transfer into the volumetric flask. Okay, transfer to volumetric flask through a filter funnel. Okay, rinse the beaker, filter funnel with distilled water, and then you transfer the rest. Okay, why? Because if you don't rinse, the beaker, if you're like you all drink Milo lah, okay, when you all drink Milo, after you drink finish already, some of the Milo will stick on the wall. Same thing your chemicals here. If your chemical from beaker you transfer to volumetric flask, the chemical might stuck on your beaker, the wall of beaker. So you have to rinse the beaker, the filter funnel with distilled water, and then pour the rest into the volumetric flask. Once everything go in already, now it's time to slowly add your water until he touched the calibration mark. So from here, you see, distilled water added until approaches calibration mark. Using a dropper, add distilled water slowly until the meniscus level aligned with calibration mark. I believe you all know what's meniscus level lah. Finally, all done already. Close the flask with a stopper. Shake well by inverting the volumetric flask several times until the solution is homogeneous. Guys, this is the 7 marks of the procedure of standard solution preparation. Can? Okay, guys. So this one, guys. if you all forgot, standard solution actually got two different ways. The first way is by starting with powder, like making Milo. Okay, making Milo. I start from powder. I measure the mass. I calculate how much mass I need. I take the mass, add into water. Water add into the powder. You prepare a standard solution. Okay, now. But sometimes standard solution can be prepared from another starting point. Means you don't start with a solid. Instead, you start with another solution. Means your teacher give you a concentrated chemical. Your teacher want you to prepare a diluted chemical. In simple, guys, we call it a dilution. So this one, guys, is when you see the word weigh, when you see gram, this one we call it weighing method. Weighing method. We have a second method called dilution method. What is dilution method? Guys, in the next page, you see the last page. Okay, the first half, right, is by potassium hydroxide solution from solid. So this one is still weighing method. Yeah. As long you're beginning, you start from a solid, you're gonna use weighing method. Okay. But then in this question, if you read through a bit, they say after you prepare from a solid potassium hydroxide, subsequently explain how would you prepare another solution is still potassium hydroxide. But do you see it was 1.0 from the first experiment? Then the second half of this question want you to prepare a same solution but with a lower concentration from the above solution. It means that your teacher want you to do weighing method first, then take this product, convert it. I mean, you want it to produce into a next solution, which is in lesser concentration. So what happened is, you see, prepare a diluted solution from stock solution. Guys, stock solution usually is the concentrated one, concentrated. And then the one that you are trying to prepare is always diluted. So this method is called what? Dilution method. So how do you do dilution method? We have a dilution formula. What's the dilution formula? M1V1 equals to M2V2. Okay. All you need to put in is, okay, what is V1, what is M1, V1, M2, V2? Okay, M1 is the original concentration. Okay, so, okay, this is your 1.0, you see, original concentration. And then your M2, V2 is the one that you try to produce. Okay, you want to produce 250 cm³ and 0.1 mole per dm³, right? I will say this is M2, this is V2, this is M2. Right? This is the thing that you want to produce. Okay. So guys, how do I differentiate these two methods? Weighing method is like making a Milo. Dilution method is like making a Ribena. Guys, have you all drink Ribena before? Ribena usually, if you buy from supermarket, you buy the very sweetened, the concentrated Ribena kind. So what you do to make Ribena? You pour a bit out, the rest you add water. Kind of. So the important part right here is how much of the concentrated you need to pour out. Takkan you pour all out and then you add water the rest. No ma. You need to calculate how much from the concentrated, the stock solution, you have to pour out how much, and then the rest you can add water. So from the calculation, you see, I will be calculating the V1. Why calculate V1? Because you need to know how much the concentrated you need. So once you calculated V1, you only need 25. The rest you add water. Then you can actually dilute your concentration from 1.0 to 0.1. Do you see it makes sense? You see, it was 1.0. Do you see you want to dilute it become 0.1? Do you see it's like 10 times lesser, 10 times less diluted? So do you see volume? You only need 25. From your 250, you only take 25. The volume and the concentration, the ratio is there one. I want to dilute this thing to be 10 times lesser. I only use 10 times lesser volume. Okay now. So put in your V1, okay, calculate your V1. Then guys, dilution method very simple. Take your original solution, okay, take a 25 cm³ using a pipette, guys. For dilution method, you're gonna use a new apparatus called pipette. Because pipette is for you to transfer chemical easily, okay, in a very accurate measurement. Then distilled water is added, okay, until the graduation mark or calibration mark, up to you. close the volumetric flask with a stopper, shake well, and until homogeneous. Okay, guys. So overall, we got two methods for standard solution preparation: weighing method and dilution method. Okay, now guys. So hopefully this one you all try your best to memorize. I give you more than enough question. All you all have to do is do it yourself one time. Okay. If you cannot do it yourself one time, you say teacher, wow, very hard. Never mind. You copy one time first. You copy all the answer one time. Then the second time, try not to copy. Okay. So you practice more lah, technically, guys. Can lah. All good ah. Okay, guys. If okay leh, I think until here is the last question already. Can ah. So guys, any updates on the tips of Selangor paper, you all let me know. Okay? Because this is only what I received until now. Can lah. You can send the tips again. Okay, can. Because the tips is in BM though. Let me copy. Okay, I send it to everyone again. This one, any tips, update me, okay? Update me, then if you need more explanation, okay, guys, if you need more, if you want to ask question, you all can WhatsApp me, okay? Okay, WhatsApp me if any question. Okay, all good. Guys, all the best for your coming exam, okay? So you can keep this PDF, you can print out this PDF, okay? And then you can actually try to do it yourself. All the best, okay? Guys, thanks for coming on a Sunday morning class, okay? Even though it's not a very morning class. Okay, so guys, I will see you with good results. Okay, bye-bye. Bye, guys. Bye-bye. Bye-bye, bye-bye, bye-bye.